Hello and welcome to Spaced Out. I'm your host Sarah Begum, and today I'd love to introduce my guest from the European Space Agency, Gerhard Kminek, Mars sample return scientist, along with his colleague Geelen, the European Return Orbiter Systems Engineering Team Leader. Welcome to the show. So the International Planetary Protection Guidelines are being revised in preparation for these Martian samples, with an update to incorporate the latest modern technologies. I'm interested to know, what are these latest modern technologies that you'll be using?
We had a number of science teams, international science teams, discussing this for decades. And the consistent message we always get was that, first, we don't know if there's life on Mars. Some people say the chances are not good, but you cannot definitely say that or defend such a position. So what we always do is we assume there's life there. So from a safety point of view, we assume there's life. And despite the fact that a lot of, most of the scientists tell us there should not be an issue in terms of being a problem for our biosphere, we assume there is an issue. And so we apply the precautionary principle, and this now leads into the ways we will deal with the sample. We contain the sample, means it cannot escape and interact with the terrestrial biosphere, or we sterilize the sample. And of course, when you sterilize the sample, then you can then you don't have, even if there was a hazard in there, it would not be in there afterwards. So these are the two avenues we follow. We contain or we sterilize. And in terms of doing actually this, we apply good old engineering approaches that can be tested and that are very robust. So it's not about inventing something new that has never been done before, and you test the hell out of it so that you actually convince not only yourself, but also the regulatory authorities that at the end have to sign off on that, and also the general public, of course.
So are there many implications legally around retrieving these Martian samples?
Well, there are regulatory implications in there because it's an extraterrestrial material we bring to Earth, and it's an unknown material. So there are, of course, issues that we have to watch out for, because first of all, we bring extraterrestrial material to the Earth, unknown material, and so there are a number of agencies, federal agencies, that will have a say handle with it and what we have to do and make sure that there's no threat to the terrestrial biosphere. The final setup is not complete yet. The samples will land in the US, so it is mainly an issue that the US has to assess and set up, but because it's an international mission, and because any consequence would not be, of course, only limited to the US, but beyond that, this is coordinated also internationally. So this process has started already a few years ago and will culminate in something that will be a sort of an interagency board at the end will decide what to do with it, similar to what has been in place already for the Apollo program.
Okay, great. And what can you tell us about the spacecraft being deployed for this mission? How will they be powered, controlled, and who is making them? Is this a question for Kelly?
Okay, well, there's many elements, many spacecraft. So, of course, the first element, the Perseverance rover, is a NASA one. Then the Earth Return Orbiter is a European contribution, but even then, it has the capture and containment system that will be there to make sure that these samples are contained, and the Earth Entry Vehicle, which are provided by NASA. So it's a big collaboration. On the European side, the Earth Return Orbiter is primed, so the main industrial contractor is Airbus in Toulouse, but they employ basically different companies across the whole of Europe as well. So they're working also with Thales Alenia and lots of smaller companies as well. Then the Sample Fetch rover is also a European contribution, which is primed by Airbus in the UK, Stevenage, who's also building the ExoMars rover, so they have the experience there. But for example, again, even on the small rover, the wheels are provided by a research center, Geelen Research Center in the USA. So yeah, big collaborations. On the NASA side, for the Mars Ascent vehicle, you've got Marshall spaceflight. For the entry vehicle, there's actually not just Goddard involved, but also Langley Research Center, Ames. So yeah, I think to make such a thing work as Mars sample return, you have to use the best of the best that you can get, and that's exactly what we're doing. So we're picking all the best people, best placed position to and with the best experience possible to build up a team like that.
What are the targeted areas of research on the samples, and what are the specialised scientific investigations that will take place to understand them? And this could be from an engineering perspective.
Some atmosphere, first one from the Viking mission, of course, but the aero bars on these measurements are very big. Then we have some atmospheric measurements of inclusions, atmospheric gas inclusions in the meteoroids, but the volumes are so small that you cannot do a very accurate measurement. So this time it will be the first time that we can actually measure, and that will help us to understand actually where the atmosphere is today, but also helping us what happened in the past in terms of the atmosphere. And then of course we look at the rocks, and there we want to look at the chemistry of the rocks and how the environment looked like when what was the chemistry of the water. So that's things, and we cannot do it with the meteorites we have. A minor actually age dating. We always say, oh, this is that old, or this is younger, but these are all relative ages with very large error bars. We don't have a very clear Mars chronology yet. The moon is our clock for the solar system, because for the moon we have not only the crater dating that we can do, we also have samples that we analyzed on Earth. So we can match how many craters we see per certain areas, and then we do it on Earth with the Apollo samples. On the because we don't have any other clock, we use this for everything else in the solar system, knowing exactly it's not correct. So for Mars, we really want to have good age dating when things happen, and this starts at a small understanding. Global process is better. And then last but not least, we look for life. And looking for life is, we don't have a magic tricorder example. We have to do basic lead us to the search for life issue, and hopefully to a positive result.
How accurate will the study of these samples be if they're Martian atmosphere signatures mixed with the surroundings of the Earth?
Well, that's exactly what we want to avoid. So the measurements we can do on Earth that we have to make, we want to analyze the things that would be affected by a terrestrial overprint in a way that we avoid the terrestrial overprint. That already started almost a decade ago. It will be used starting next week when the Mars 20 to actually acquire the samples.
How would you ensure the best science is achieved on the samples, and in which parts of the world will they be sent to for laboratory research?
The best way to make sure that we get maximize the science return of this mission or this campaign is to make public announcements at the international level, and that's what we plan to do. There will not be scientists selected that are not going through a competitive selection process. And this, for decades, we do this when we send instruments to other planets and moons, and we will also do that when we bring the samples back to Earth.
And why is this Mars sample return campaign so important and significant for humanity on Earth?
Well, one aspect of that is, of course, history. Where do we come from on Earth? We don't know that, but so we have to go to another place in the solar to find out more. So this is one of the things that would be information that we could get from the samples from Mars. This is an international cooperation planet that have to work together on the engineering side, have to work together on the science side, independent of everything else that happens on this planet, independent of political issues, independent of natural catastrophes, independent of the pandemic we have now. So having these international endeavors always provides an avenue to foster international collaboration that otherwise would be difficult to achieve.
But are there any preconceived notions of what signs of life may be found on Mars from the Martian samples themselves?
We don't wonder how Mars life would look like. The minimal ground that we agreed on is we look for organic chemistry. But we expect any life would be based on organic chemistry. When you look for life, you can look at two things. You can look directly for the life form, or you can look at the effect life has on the environment. We have a big effect on our environment. We as people have a big effect on the terrestrial environment. You can see that. You can see that also from space. You could see that from another solar system when you would look at our atmosphere. But this is also true at the microscopic scale. Every microbe affects the environment around it. That is sometimes the easy way to find indications of life. Not to look for the bug, not to look for the individual microbe or for some friends of the microbe, but for the effects of life on the environment. So when we will look for life in the samples we'll get back, we use both avenues. Of course we will see and if we can find some life. Well, we will look for life directly, but we also look for changes in the environment that could be induced by life that we cannot explain by physics or chemistry, that could only be done by biology.
I'm just fascinated by the notion of life on Mars and what kind of life this could be. It's just, it could mean so many things for us, and just open up the expanse of our horizons, and it's just fascinating for me. But how will this prepare the future human exploration of Mars? Because eventually we want to send people to Mars. Elon Musk is talking about creating a city on Mars. We want to colonize Mars, and that's going to be one of the next biggest missions for astronauts going to Mars. So how will this project, this campaign, prepare the future of human exploration on Mars?
I think Mars sample return will be the first sort of journey there and back. And I think we will learn a lot when we look at the samples on the hazards, what the materials really are like, so that before we send people or humans, that we know what the dangers are that maybe currently we're not aware of. So it will sort of take away some of these risks for sending humans to Mars, in that aspect.
If we study the samples that we'll get from Mars, this will inform our risk posture. We will better understand what kind of chemistry we have in the soil, what chemistry we have in the dust. It will inform our risk assessment of a human mission to Mars, part of the risk assessment of a human mission to Mars.
Okay, great. And final question. It's been great speaking to you both, and I'd love to know, in a very short answer, just how you got involved in this mission and why you wanted to work within the space industry.
Okay, for me, it was one clear event, the Mars Pathfinder landing in 1997. Seeing the animations and the first images of the lander with Sojourner rover sitting on top of it with the bouncy airbags sort of around it. That's when I decided I want to work in space and I want to send things to Mars.
Oh,
so
wow.
That's really
back.
what.
How old were you? Like 5?
No, 16. So.
Wow. Okay, that's amazing. And what about yourself, Gerhard?
Well, I was, I think in 1996, I was jobs was to help the Red Book, The Science Rationale for Mars Exploration, including Mars Sample Return. And that's why I got interested in this. At the end, I did something else for a while, but now I'm back.
Okay, cool. Thank you so much for your time and incredible and invaluable knowledge. I've learned so much. I'm really excited about this mission, about future explorations on Mars. And I can't wait to see what you guys discover. This is really exciting. I'll be following it closely. Thank you. Thank you so much for being on the show.
You're welcome. It was interesting for me too.
Thank you.